Good afternoon, students. Welcome back to my YouTube channel. Presenting before you this wonderful tutorial is Hampio Kliman. And of course, if you are new to this channel, consider subscribing and also hitting the like button, and don't forget to share to others. Today I bring you very important concepts you have to learn under electricity. Let's get started. Suppose you have been given mass of a particle to be, let's say, A. And you have been given the electric field. Let's say the electric field is B. Then you are asked to simply find the magnitude of a particular charge. Okay, so now we know that the electric field is equal to the force over the charge. Force is equal to the mg in this case. And of course, the force that is acting on this charge in this case is the weight. So this can also be written as the electric field is equal to the mg over the charge. So if we want to find the charge, this is going to be the EQ equal to the mg. So the electric field is going to cancel on both sides, and in this case our electric field is going to equal our charge is going to equal to the mg over the electric field. So in this case, notice that our mass is A, so we're going to put our A here, and we have 9.8 here over, what is the electric field? The electric field is B. So this is how you calculate the charge given the mass and the electric field. Now, how do you determine the charge? Sign. How do you come up with the sign of the charge? Well, the direction of the electric field is going to guide you. So if an electric field is due upward, and you imagine that you have a test charge that is positively charged, you expect it to be moved in this direction. If the electric field is in this direction and our test charge is particularly here, we expect the charge to move in this direction, and therefore it will gain a positive sign. So depending with the direction of the electric field, you can come up with the sign of the charge. Okay, so that is very simple. Now, let's try to derive some formulas. How about if a charge feels an electric field? How about if you have a scenario of this case? You have a hanger, then you have a charge of this type. Notice that imagine that you have an electric field in this direction. Charge Q1 is going to feel a force due in this direction. So if this be our case 1, case 2 is going to possess this particular diagram. So we're going to have our Q1 in this direction. Okay. Now, notice that there is an angle of deflection which we can simply call theta here. Now, the direction of the electric field is in this direction. Meaning, there is a force that Q1 is feeling and the force is due in this direction. And we can call that force the Coulomb force. But notice, according to Newton's first law of motion, if you have a stone on the ground and you exert a force in this direction, and we call it force 1, there is another force which is acting in this direction, which we call the opposing force. So Q1 is feeling a force due in that direction, but there is another force that Q1 is experiencing, a force in this direction, which we're calling as the opposing force. But in this case, this force is the tension force. Notice that test charge Q1 is also experiencing a weight. There is a force that is pulling it downward in this direction. And we call this force the weight, which is equal to the mg. At the same time, Newton's third law of motion, if there is a force pulling downwards, which we are calling as the weight, then there is a force pulling upward, which we are simply calling as the force, the opposing force. So there is a force which is acting upward, opposing the weight. And of course, this is a tension force. Now there is something that is very important that we need to look at. Remember trigonometry. Under trigonometry, there is something that we call SOHCAHTOA. Now, sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. In this case, notice that the hypotenuse is this side. Notice that the adjacent is this particular line here. Notice that the opposite is this line. Now, if this line here is the opposite, and opposite is found in sine, then it means that this tension force is T sine theta. Notice that the adjacent is found in cosine, meaning this tension force due upward is T cosine theta. All right. Having noted that, we can now come up with our formulas. Summation of all forces in the x-axis, there is a force which is acting in this direction. We are calling it the Coulomb force. It is being opposed by this force acting in this direction, so minus the tension sine theta, and everything will give us 0. That's the net force. Equation number 2, summation of all forces in the y. We have this force acting in this direction, and we are calling it a force of gravity, minus there is a force acting due upward, which we're simply calling it as the T cosine theta, and of course that equals 0. If we solve for this, notice that the Coulomb force is going to equal to T sine theta. We can name it as equation 1. Force of gravity is also going to equal T cosine theta, and of course we name it as equation 2. You use this particular concept when an electric field is causing a diffraction angle. Now, we can make T the subject, so we're going to have Fg equal to T cosine theta over cosine theta cosine theta. If we cancel out, we have our tension equal to the Fg over cosine theta. And of course, the same thing can be done to the Coulomb force. And our tension, if we make T the subject, our tension is going to equal to the Coulomb force over sine the angle theta. All right. Let me just try to create some space. Now, we have this. Let me just try to put it here. And of course, we have this. We can also take it here. Okay, so having done this, let's now try to notice that t is equal to fg over cosine theta and t is equal to f over cosine theta. Upon reaching here, this t can replace this t, and that means that fg over cosine theta is going to equal to fc over sine theta. Cross multiply, we have fg sine theta equaling fc cosine theta. Now notice that we want to find the charge of this particular particle. So how do you find the charge? Meaning we concentrate on the Coulomb force. So we're going to divide by cosine the angle theta, even this side cosine the angle theta, and if we cancel that, we have the Coulomb force equaling the Fg. Now notice that this is a trigonometric property. So sine theta divided by cosine theta is tan theta. And of course, we can replace with our mg here, where there is the force of gravity, tan the angle theta. Now this even makes sense because we know that the electric field is equal to the force over the charge, meaning force is equal to, meaning force is equal to electric field over the charge. This means that the Coulomb force can be replaced by the electric field multiplied by the charge equal to the mg tan the angle theta, and of course over E, and of course over E. And if we cancel out, we shall remain with the charge equal to the mg tan the angle theta over the electric field. And this is how you find your charge in coulombs given the electric field as well as the mass as well as the angle. Thank you so much.